want to say one more thing about multi-loop circuit. So we had our multi-loop circuit last time. Okay. And if you look at old exams, you can see that I'm probably going to have a circuit of this sort for you to do. So you need to know how to do it. You need to know how to do it correctly. There are common mistakes that students make all the time. Students will often automatically just write down I1 plus I2 equals I3 because that's how the book does it. Notice that was not true the way I defined the previous circuit. Now, if I had, what I had done was I defined that as I1, that is I2, and that is I3. Now, in that case, then it was not correct to say I1 plus I2 equals I3. Instead, I1 plus I3 equals I2. Well, there's another way here. You know, what was really happening? What was really happening was the current was going that way. If you had realized the current was doing that at the very beginning, and actually I've done enough circuits that I could tell by looking at the circuit that's probably what was happening, I could have picked that. And I could have picked the current going backwards through the battery if I thought that's what was happening. But now the equation is I1 equals I2 plus I3. Again, it's not I1 plus I2 equals I3. Okay, but if I had instead defined it so that this was I2 and that was I3, then I1 plus I2 equals I3. Okay. Okay. Of the possible combinations here, the one that works is the one that's based on your drawing and your labels. The direction that you pick the current defines the plus and minuses of those resistors. If you change the direction of the current, then that changes the plus and minus of the resistors. It does not change the plus and minus of the battery. That does not ever change. But the direction of the resistor, always when you have a resistor here, if the current is going in the resistor, it always goes plus to minus. Now, if you come up with a negative value for current after you solve it, you know you picked the wrong direction and really you had it backwards, but that's okay. You know, when you're setting up the problem, you define it. You define which current is I1 and which current is I2 and which current is I3. You then define what direction you think it's going. That defines which is the plus and minus sign of the individual circuit element. So if this side's minus and plus, if your loop is going this way, that's going to be plus IR. Okay. On the other hand, if this side is plus and that side is minus and your loop is going that way, then that's minus IR because you went from plus to minus. Okay. So whether it's plus IR or minus IR depends. Okay. If current goes that way, this is plus, that's minus. So a loop going this way is going to be minus IR. A loop going that way, so if the loop is going this way, that's minus IR. If the loop goes the other direction from right to left, then you're going from minus to plus, so that's an increase of IR. So whether you go minus IR or plus IR, that depends on the direction you chose for that resistor and for the current. Okay. Got a power supply. If my loop is going this way, then that's going to be plus V because that's minus and that's plus. On the other hand, if my loop goes that way, then I'm going from plus to minus, so that's minus V. Okay. Always, if you go from plus to minus, that's negative. If you're going from minus to plus, that's positive. Okay, so those are some of the mistakes that students make. Okay, so first most important thing for any of your circuits, and you can have any number of things here. You could actually have multiple sort of things here. You could have a circuit that looks like that if you wanted to. Okay, and then what you would do is you would say, okay, I've got current here, I1, I got current there, I2, I got current here, I3, I got current going there, that's I4, I got current there, that's I5, and I got current this way, that is I6. So every time you get a junction, you would say, okay, current in equals current out. So I5 plus I6 equals I1. Up here, junction. Oh, wait. I have I1 plus I2 plus I3 equals 0. I picked all of those going in. That means obviously one of those is actually negative. Okay. And I obviously picked one of those currents wrong. Okay. Because it can't all, I mean, they cannot all add up. You know, three things cannot add up to be 0 unless one of them, at least one of them is negative and one of them is positive. So at least one of those is wrong, if not two. Okay. So again, what you would do is every junction you would add things up. Now, even though I know that one of these is wrong, I can still work the problem. I would have a loop here, I'd have a loop there, I'd have a loop there. I could have a loop around the outside if necessary. All I got to do is have enough loops and enough junctions so that there are 6 possible currents here, so I have to have a system of 6 equations to solve, 6 independent equations to solve. And so that's all that you need for this problem here. Okay, now that's annoying. Got a system of 6 equations, 6 unknowns you got to solve, but that can be done. There are ways of doing that. Okay, I would not actually ask you something like that on the test, but you could use this Kirchhoff's rule to do. Okay. So once again, a common mistake that is frequently made, okay, almost always made, on every time I grade this, that almost every semester a student makes the mistake, and that is they just blindly write down I1 plus I2 equals I3 without checking to see if that's true. Don't write that down. Don't write it down until after you have defined your currents. If you say that's I1 and that's I2 and that's I3, then yes, that holds. Okay. But you need to define your currents to begin with, and then you can define, what's what. Okay, and that's how you avoid mistakes. I give a problem like this virtually every semester on the second test, and I'm warning you now, expect a problem like this, and learn how to solve problems like this. There's homework problems like this. I did an example problem like this. There's be a lab problem like this. Okay, so what you want to do is learn how to do this, because you're going to be asked how to do this. Do a problem like this on a test, and so that's just just a given. Okay, draw the circuit. Label the current. Draw the currents and label the currents. That is how you figure out what the junction equation is going to be, is from the currents that you drew. Okay. It is sometimes helpful to draw them in different colors so they stand out. Then you label the pluses and minuses of everything. If you're going in the direction of the current, that's plus and minus. That's plus, that's minus. That's plus, that's minus. Go in the direction of the current. That tells you the plus and minus. Okay, label that. Don't just assume it, label it, because that will help you when you're actually creating your equations to solve. Okay, and then in a separate color, and I like in yet another color to draw whatever loop I'm doing, and it doesn't really matter. Your book always goes clockwise for all the loops. I don't always do that. I use whatever direction gives me the fewest minus signs because I just don't like minus signs. And so it doesn't really matter. Pick a direction and go with it. And if you're going from minus to plus, that is an increase. So that's positive. If you're going from plus to minus, that's a decrease. And so that's negative. And so that is how you do this. So you create, you draw your circuit, label everything. I like to do it in all different colors so that it's less of a mess, and you can just glance at it, and you know this color represents that. Okay, and then you work through, develop your equations, and then solve them. Okay, system of equations. However you want to solve your system of equations, solve them. Okay, this problem gives people fits every semester. And mostly it's because they don't follow the instructions I give as to best practices for solving it. If you follow the best practices for solving it, it works a lot better, and then the only mistake you make is possibly an algebra mistake. And I take off a whole lot less for algebra mistakes than I do for the fundamental mistake of setting up the equations wrong.